What if Earth had no electricity for a week? Could space tech survive? Imagine waking up tomorrow morning, and nothing turns on. No phone screen. No lights. No hum of the refrigerator. No Wi-Fi signal quietly blinking in the corner of your room. At first, you'd think it's just your street. Then your city. Then, the whole planet. No warning. No countdown. Just silence. This isn't science fiction. Earth has come dangerously close to exactly this scenario before, and if it ever happened for a full week, the damage on the ground would be catastrophic. But here's the real question this video is going to answer. What happens above the ground? Would our satellites survive? Would astronauts on the International Space Station be stranded? Would humanity's eyes on the universe go blind? Let's break down, day by day, what a week without electricity would actually look like, for us, and for everything we've built in space. Setting the scene. Before we jump in, let's be clear about the trigger. This isn't just the power company forgot to pay the bill. We're talking about a global-scale event, like a massive solar storm, similar to the Carrington event of 1859, but bigger, hitting a modern, electricity-dependent world. In 1859, a solar storm was so powerful that telegraph wires sparked and caught fire, and that was in an era with almost no electrical infrastructure. Now imagine that same storm hitting a planet running on satellites, power grids, and data centers. Scientists have warned, a Carrington-level event today could take down power grids for weeks, not hours. So let's start the clock. Day 1. Day 1, the ground goes dark. Within minutes, hospitals switch to emergency generators, but those only last hours to a few days at most. Traffic lights die. Cities gridlock. Communication towers lose power, and cell networks blink out one by one. But up above us, 400 kilometers into orbit, something else is happening. The International Space Station doesn't rely on Earth's power grid, it runs on its own massive solar panels and battery systems. So the astronauts themselves are fine, electrically speaking. The real danger for them is communication. Mission control facilities on the ground, like Houston and Moscow, depend on regional power grids. If those go down, the ISS could lose contact with the ground for the first time in decades. Astronauts have training for this. But losing constant contact with Earth, indefinitely, is something no crew has ever truly experienced. Day 2 to 3, satellites start losing their voice. Satellites themselves aren't directly powered by Earth's electricity, they generate their own power from solar panels. So physically, most satellites keep functioning. The problem is us. Every satellite needs a ground station to send commands, download data, and stay calibrated. If ground stations lose power, satellites essentially become orphaned, still flying, still working, but unable to talk to anyone. GPS becomes unreliable within days. Airplanes lose precise navigation. Ships at sea have to fall back on old-school paper maps and compasses, tools that haven't been necessary in decades. Weather satellites keep taking pictures of storms forming, but with no ground stations able to process and distribute that data, we'd be flying blind into severe weather with zero warning. This is the strange irony of a blackout. Space technology keeps working. It's us who lose the ability to use it. Day 4 to 5, deep space missions keep going. Here's where things get genuinely fascinating. Spacecraft like Voyager 1 and 2, now billions of kilometers from Earth, run on radioisotope thermoelectric generators, which convert heat from decaying plutonium into electricity. They don't need Earth's grid. They don't even need sunlight. Mars rovers like Perseverance use a similar nuclear power source, letting them keep operating regardless of what's happening back home. So while Earth goes dark, our farthest flung machines just keep going. Perseverance keeps drilling. Voyager keeps sending its faint signal from interstellar space. The catch? Without power at NASA's Deep Space Network, the giant dish antennas that pick up these faint signals, nobody on Earth would be listening. The data would keep streaming out into the void, unheard, until power came back. It's a strange thought, our most distant explorers, built to survive without us, patiently waiting for humanity to plug itself back in. Day 6, the human cost starts to compound. Water treatment plants need electricity to run pumps and filtration, meaning clean water access starts failing in many cities. Refrigeration for food and medicine collapses. Backup fuel supplies for generators start running out, because fuel pumps themselves often need electricity to operate. Financial systems, banking, and food distribution networks, all of it quietly grinds to a halt. Compare that to the astronauts on the ISS, floating above all of it. They have stored food, recycled water systems, and independent power. Day 7. What recovery looks like. Recovery from a real Carrington-level event wouldn't be instant. Damaged transformers, the heavy equipment step-down power for cities, can take months to manufacture and replace, because most countries don't keep large stockpiles of spares. Power would likely return in stages, hospitals and emergency services first, then key communication infrastructure, then slowly, neighborhood by neighborhood. For satellites and the ISS, the moment ground stations flicker back on, contact resumes almost immediately, because the hardware in space was never actually broken. It was just waiting. So, could space tech survive a week without electricity? Mostly, yes. Satellites keep flying. The ISS keeps orbiting. Voyager keeps whispering data across the solar system. Nuclear-powered rovers on Mars keep working exactly as they were designed to. It's a humbling thought. Humanity has built machines that can survive alone in the vacuum of space for decades. But we still haven't built a power grid that can survive one bad week on our own planet. If this made you think differently about how fragile, or how resilient, our technology really is, hit subscribe. Nova Research breaks down one what-if space scenario every week, and trust me, the next one's even wilder.